Hello, I'm Dmitri from Puzyrev, and in this video we will discuss the concept of active learning and how we can use it. What is active learning? Active learning is a machine learning framework in which learning algorithm can interactively query a user, which can be a teacher or an oracle, to label new data points with true labels. The process of active learning is also can be referred as optimal experimental design. The motivation for active learning is a scenario in which we have a large pool of unlabeled data. Consider the problem of training an image classification model to distinguish between cats and dogs. There are millions of images out there for each, but not all of them are needed to train a good model. Some images may offer more clarity and information than others. Active learning framework is also useful for professionally specific datasets, such as medical records or biological records and so on, because labeling for such data requires much more expertise and or time from the professionals. The main idea is that by using active learning, we can selectively leverage a system like crowdsourcing to ask human experts to selectively label some of the items in the dataset, but not to label the dataset entirely. The algorithm iteratively selects the most informative examples based on some value metric and sends those unlabeled examples to labeling oracle, who returns the true labels for these queried examples back to the algorithm. Active learning is considered to be a semi-supervised learning method, between unsupervised being using 0% of the learning examples and fully supervised learning using all 100% of the example. By iteratively increasing the size of a label training set, we can achieve greater performance, near fully supervised performance, with just a fraction of the cost of time to train using all the data available to us. All active learning procedures can be divided into two categories: pool-based and stream-based. In pool-based sampling, training examples are chosen as a small subset or from a large pool of unlabeled data. Selecting training examples from this pool are labeled by the oracle. In stream-based active learning, the set of all training examples is presented to the algorithm as a stream, one by one. Each example is sent individually to the algorithm for consideration. The algorithm must take an immediate decision on whether to label or not to label this example. Select training examples from this pool labeled by the oracle, and the label is immediately received by the algorithm before the next example is shown for consideration. The active learning framework reduces the selection of data to a problem of determining which are the most informative data points in the set and which are not. But that is usually meant that the most informative data points are generally the ones that the model is most uncertain about, because it can learn more from it. This necessitates various metrics to quantify and compare uncertainty of the examples. The intuition here is that examples for which the model has the least certainty will likely be the most difficult examples, specifically the examples that lie near the class boundaries. The learning algorithm will gain the most information about the class boundaries by observing these difficult instances. Let's discuss this intuition behind various uncertainty metrics. First, we start with least confidence uncertainty. It is defined by selecting the example for which the classifier is least certain about in the class selection. It can be checked by looking at class probabilities at classifier prediction. Least confident selection only looks at the most likely class for each instance and selects the example that has the lowest probability assigned to this class. The intuition here is that the prediction of this class can be proved by selecting the examples with the lowest probability, because that probably means it is on the boundary of the class. The smallest margin uncertainty is a best versus second best uncertainty comparison. It is when the classification probability of the most likely class minus the classification probability of the second most likely class. The idea behind this metric is that if the probability of the most likely class is significantly greater than probability of the second most likely class, then the classifier is more certain about example class membership. Likewise, if the probability of the most likely class is much greater, then the classifier is least certain about the examples class membership. This metric can also be modified as largest margin uncertainty, where the most likely class and least likely class are compared. The general idea in this case is quite the same. Finally, let's talk about the entropy reduction technique. In statistics, entropy is the natural measure of the uncertainty of random variable by its definition. Active learning algorithms use Shannon entropy as indicator of uncertainty because it has several useful properties. The first is that uniform distributions have the maximum entropy. So in our case, uniform distribution where each class has the equal value of probability. Also, entropy is additive for independent events. High values of entropy indicate greater uncertainty in the probability distribution. In each active learning step, for every unlabeled example in the training set, the active learning algorithm computes the entropy over the predicted class probabilities and selects the example with the highest entropy. Quite in contrast to all previous methods that we described, variational dropout technique is not based on metrics directly. To understand the proposed technique, we briefly have to talk about Bayesian neural networks, or BNNs. Bayesian neural networks, classical feed-forward neural networks where the weights are modeled as distributions. You can still take an input vector and feed it through BNN, but the result will be some probability distribution instead of a single value. In other words, if you give an input to the network, the BNN will assign a probability to each possible output. A well-trained BNN will have a high probability to labels which are very likely to be correct, and a low or even zero to labels which are very unlikely. This makes a BNN a probabilistic model and has the benefit that we get additional information from the network. Actually, it was proven that neural networks with a single layer converge to a Gaussian process when the layer width is taken to infinity. Why is it important and beneficial to us? Gaussian processes have the nice properties that they are completely defined by the mean and covariance. In the case of Bayesian network, the weights distributions and mean and variance can be estimated by drawing samples from the weight distributions and calculating forward passes iteratively one by one. The variance of this process is that uncertainty that we need to select the example. If a point in the pool has a high variance, the network has a high uncertainty about its prediction, and the points should be selected in our case. But if we have a non-Bayesian network, we can use dropout instead, because the other fact that was also proven is that dropout sampling approximates the Bayesian approach because dropout itself simulates Bernoulli distribution with some fixed probability. By running the network with dropout many times and summing the results, we can get increasingly better and better approximations. This kind of approach is called Monte Carlo integration, hence the name of the method itself, the Monte Carlo dropout or MC dropout. In this presentation, I presented to you the concept of active learning. It helps us solve the problem of memory consumption of large datasets, problems with data labeling, especially for datasets where specific costly expertise is needed to outline the labels. The process consists of iteratively increasing the size of our label training set as the most informative examples based on some value, which is usually called uncertainty. Then the Oracle labels these examples and we get new enriched dataset that we can train on. The process can be either pool-based, where a subset of examples is selected, or stream-based, where examples taken one by one. The value which selects the examples can be formulated by metrical approach with the techniques such as least confident uncertainty, maximum entropy, or margin uncertainty, or by a vote of a committee of predictors with variational dropout technique, which is defined as Monte Carlo dropout or MC dropout. If you're interested to investigate more in active learning strategies, I highly recommend to you the libback library in Python. You can see a link in the description below. and feel free to investigate more on the concepts of active learning. Thank you for your attention. If you want to know more about machine learning, you can subscribe to this channel, give us a like and click the bell button. Thank you very much.